I don't know about you, but I'm always tempted to just start writing an application using lower level data access APIs. I just want to get started with a project, get it done, and then move on to the next project. And this is especially tempting if I'm using Entity Framework code first, because the data access code is made up of nothing more than just plain ordinary classes. And in the case of our Ribbit application, we are going to use those classes throughout our application, but we're not going to use it within the realm of data access. Things like creating, reading, updating, and deleting. Those are things that we want to separate from the rest of our application. We want to isolate that data access code within its own container, so that then we can swap out that container with another container if we decide to change to a different database, like going from Microsoft SQL to MySQL, or even to a NoSQL database. We can make these changes if our data access code is isolated from the rest of our application, and most of the time it will have minimal impact on the rest of our code. One of these types of containers is the repository. It's a common pattern used to work with different types of data. For example, we are going to create a user repository and a Ribbit repository, and these two repositories work specifically with user objects and Ribbit objects, but only within the context of data access. So it's going to query the database, it's going to insert new records into the database, update them, delete them, and things like that. There will also be some specific functionality for the different types of data, like we might want to retrieve a user based upon an ID or a username. We also might want to retrieve a Ribbit based upon a particular user. And we do have that functionality built into our Entity Framework classes, but we also want to provide an API that we can use without Entity Framework. But before we start writing our repository classes, we need to revisit our Ribbit database class, because we need a constructor that calls the base classes constructor, passing in the name of our connection string, because Entity Framework needs to know what connection string to use. So we are going to type public, then Ribbit database, and then this is going to call the base constructor, passing in the name of our connection string, and then that's it. So this default constructor will initialize our DB context with the appropriate connection string. So let's close this file, and let's get talking about our repositories. Now, I mentioned that these repositories are essentially containers that contain our data access code. And in order to make them interchangeable, we kind of need to use an interface. So I'm going to add an interface to the project. I've already written this, and this is an interface that I use quite frequently for this particular type of pattern. It's simply called iRepository, and it defines a set of methods for creating, reading, updating, and deleting. We have a method called all, which will retrieve all of the records within a particular table. We also have an any method to determine if there are any records that meet a particular criteria. We also have the count property to get the amount of records within the table. Then we have create, we have delete, passing in an entity object. We also have a version of delete that accepts a predicate. So we can delete multiple records based upon a particular criteria. We can find a single record within the table, or we can find multiple records. This second find all method has an index and a size. So if we needed paging, we could use this method. And then finally, we have an update method, where we pass in the updated entity. Next, we can write a concrete class that implements the iRepository interface. And this concrete class can be specific for Entity Framework, so that we can reuse it in other projects if we wanted to stick this in its own class library. But in our case, it will be reusable for our three entity classes: our user, our Ribbit, and our user profile. So let's add a class to our data folder, and I'm going to call this EF, short for Entity Framework, repository. This will be a generic class, and it will implement iRepository of T. And we'll let Visual Studio go ahead and stub out the interface. We can also set a constraint for T so that T has to be a class. So where T is a class. Because this class will be specific for Entity Framework, we do need our DB context. So let's make this a protected field of type dbContext, and we will just call it context. Something else that we should consider is that we might be sharing the same context between different repositories. In the case of our application, we will want to have the same context for the user, the Ribbit, and the user profile repositories, because Entity Framework is a connected ORM. We'll typically want to use the same context throughout the lifecycle of a single request. So let's add a property. This will be protected as well. We can also make it read-only, and this will be a Boolean called share context. And using this variable, we can control the behavior of our repository in relation to our context. Let's write a couple of constructors for this class. The first constructor is going to just accept our context. The second constructor will accept both the context and the share context value. So let's start with the first constructor. We want a dbContext object. And this is actually going to call the second constructor. So we'll go ahead and write this code even though it does not yet exist. So context, and then we could set the default value to true, because that's pretty much what we need for this application. Although if we wanted to use this same class in other projects, it would probably be wise to make this false. And then in this application, we just need to ensure that we pass in that second value of true. So we'll stick with false in this case. Our second constructor has the Boolean value for share context. We'll call that shared context. And then in this constructor, we will set our variables. So context will be context, and then share context will be equal to shared context. And since we are working with entity classes of type T, we need the DB set of this particular entity class. So let's create a protected property of type dbSet of T. We'll just call this dbSet, and this will have just a getter. This will return context.set of T. And this is the property that we will use throughout this class in order to interact with our database table. So all we need to do now is add actual implementations for the rest of the iRepository members. In the case of the all method, we just want to return dbSet as queryable, which is simple enough. The any method is also going to be simple. We will return dbSet.any, passing in the predicate. With count, we will return dbSet.count. The create method inserts a new record into our table. So we want to use dbSet.add and then pass in our entity object. And then this is where the share context comes into play. If we are not sharing a context, then we want to go ahead and save this change. So by calling the context.saveChanges method, that will initiate that transaction, and our new record will be inserted into the table. And then we want to return our entity. The delete is going to be very similar to the create, but instead of calling the add method, we call the remove method. We want to check if we are sharing the context, and if not, we want to return context.saveChanges. Otherwise, we want to return 0. Now, the other overload for delete is going to be a little bit more involved. We first want to retrieve the records that meet our particular criteria. So we will use the findAll method, passing in predicate, and then our records will contain all of the records that we want to remove. And unfortunately, we don't have a remove overload that we can specify a list of records to remove. We have to loop over all of these records. So var record in records, and we will simply call dbSet.remove record. And then we want to do the same thing that we did in the other delete overload. We want to check if we are sharing the context. If we aren't, then we want to save changes. Otherwise, we will return 0. Our find methods are going to be rather simple as well. This first overload, we can just simply return dbSet.find and then pass in keys. The second overload is almost as simple. We return dbSet.single or default, passing in the predicate. Our first findAll method is simple as well. We just return dbset.where, we pass in the predicate, and then as queryable. Our second find all overload is a little bit more involved. We need to first get the amount to skip. So we will take index and multiply that by size, and that will give us the amount that we need to skip. I'm also going to create a variable of type iQueryable of t. I'm going to call it query, and I'm going to initialize it as dbset. Because our predicate could be null, we could call the findAll method and pass null for our predicate. So we need to check if predicate is not null. And if it isn't null, then we will set query equals query.where, and then we will pass in the predicate. And we also need to check to see if our skip value is 0, because if it is 0, then we essentially write code like this. Query.skip, passing in 0, and then take size. Now, this looks like a free operation, skip 0. But here's the thing, it's not guaranteed to be a free operation. The link provider does not have to optimize skip 0. So we in turn need to ensure that our code is optimized. So we need to avoid skip 0 as much as possible. So we need to check if skip is not null, and if it is not null, then we want to do query equals query.skip, and then pass in skip. And then finally, we want to return query. We want to take the amount of records specified by size, and then return as queryable. For the update method, we need to first attach the entity object to our context. We might not always need to do this, but it's always a good idea to do it just to avoid any type of issues. So we want to attach t, but before we do this, we do need to create an entry. So var entry equals context.entry, and we will pass that in. Because after we attach it, we then need to set the state. So we will do entry.state, and we want to say that this has an entity state of modified. And then, like create and delete, we want to check if the share context is false, and if so, then we want to call context.save changes. Otherwise, we will return 0. Then finally, we have the dispose method. So once again, we will check if we are sharing the context. If we are sharing the context, we do not want to dispose because our other repositories might need the context. So there should be something else outside of the repositories that manage the disposal of our context. So if not, share context, and context does not equal null, then we want to try context.dispose. It's always a good idea to try disposing, because sometimes you will try to dispose an object that is already disposed. And that might not be the fault of your code, it might be the fault of an ADO.NET provider. So this could save you some headache later on down the road. And so that is our base class for our entity repositories. So let's start with our user repository. Let's first add an interface. Let's call this iUserRepository. This is going to implement iRepository of user. And of course, this is not a class. This is an interface. We'll start with two methods. We might need more later on down the road, but we can always add those. These methods are going to get a user by an ID and a username. So the first is going to accept the ID. The second will accept a string for the username. And now let's write a concrete class that implements our iUserRepository. So let's add a new class to our data folder, and I'll call this user repository. It needs to implement the EF repository of user, and it also needs to implement the iUser repository. And we can go ahead and let Visual Studio implement those members for us. Let's add a constructor so that we can pass in the context as well as the Boolean value for sharing the context. So public user repository, the first parameter will be our DB context, and the second our shared context value. And then we will call base and passing context and shared context. And now let's fully implement our getById methods. These are going to be very simple. We simply use the find method, and for our criteria, ID has to be equal ID. And for the username, instead of using ID, we just use username for that comparison. So let's close those files, and let's write an iRibbit repository interface. So let's add a new class. Even though it's not a class, it is an interface. This needs to implement the iRepository of Ribbit interface. And let's have a method that returns a single ribbit, and we'll call the method getBy. And of course, it will use an ID. We also want to be able to get the ribbits for an individual user. So let's return IEnumerable of ribbit. The method will be called getFor, and we will use a user object for the parameter. It would also be helpful to have a method to add a ribbit to a user. So we want a ribbit, which we will call ribbit, and then a user, which we will call a user. So now let's write a concrete class that implements this interface. We will call it Ribbit Repository. We need to inherit the EF repository, and of course this will be of type ribbit. And we need to implement the iRibbit repository. Like the user repository, we do need a constructor. And then for the members, the getBy method, we will once again use the find method, and we will compare the IDs. For the getFor method, we are going to use our user object, and we will use the ribbits property. We'll order by descending, because if we are wanting to get the ribbits for a user, we want them pretty much in order descending. And if we want to change this, we could change this later on. But we want to order them descending by the date created, and of course we need to return that. And then finally, we will want to add a ribbit to a user. And once again, we will use our entity framework syntax. So user.ribbits.add, pass in ribbit, and then we want to check if we have a share context. If we do not, then we want to save changes. Now, of course, we need a repository for the user profile, but as you've seen, a lot of it is repetition. Of course, there would be some things specific to the user profile, but we will create that repository later on whenever we need to do so. And now we have a higher level API for data access. But that wasn't necessarily the goal of this exercise. We wanted to isolate our data access code, and we did that with a repository. And now we have the benefit of being able to swap one repository for another without breaking the rest of our application.